Okay, so let's look at this new now. We have log base 10 of 2x minus 4 is equal to 1 plus log of x plus 2. So when we're looking at this, we might think, okay, well, this is a log equals another log. We can try to set their arguments equal to each other because they have the same base. There's a problem there. There's this 1 there, this 1 plus 1. It's not part of the argument. And even if I were to subtract it on the other side, would it be part of the argument there? No, the argument is what's in the parentheses. So there's no getting rid of this 1, which sort of messes everything up for us. So we can't set argument equal to the other argument. What are we going to have to do here? We're going to move the log over. So I'm going to have log of 2x minus 4 minus log of x plus 2 is equal to 1. What do you think we're going to do now?
Turn it to division, so log 2x minus 4 divided by x plus 2.
You got it. We're going to turn it into division. So we're going to bring it down to 1 log, and that's going to be 2x minus 4 over an x plus 2. Now, I can pull out a GCF of 2 in the numerator, but will that help me simplify anything? No, because it's not going to help me simplify anything, I'm not going to do that. This is going to equal 1. So now we have 1 log with its one argument is equal to a whole number. So now we're going to change it back into exponential. So we're going to have 10 to the first power is equal to 2x minus 4 over x plus 2. At this point, we're going to need to solve for x. So I will cross multiply this. So we are going to have 2x minus 4 is equal to 10 times the quantity of x plus 2. 2x minus 4 is equal to 10x plus 20. When we go to solve this, we are going to get negative 8x is equal to positive 24. X will equal negative 3. We need to check. So we go back, and what do we realize? When we plug in the negative 3 here, won't I get a negative argument? So what does that mean? I need to reject the negative 3. Is there any other answer that I can use? No. So what is this? There's a no solution here. Yes?
Actually, never mind. I thought I did the algebra wrong. I just switched the sides.
Okay. All right, so I had told you guys we need calculators today. So if you have your calculator, take it out. I'll pull up my calculator also. This is weird. Where's my calculator? There it is. All right, we're not graphing, so we don't need that. Okay, so our instinct is not to use a calculator. We need to have the most accurate solution. So if we're able to do it by hand, you must solve the log by hand. But if we're not able to solve the log by hand, that's when we use a calculator. For example, let's say I have log of x is equal to 1.8. And I want us to solve for x. Well, we're going to change this into exponential. Do we agree this is 10 raised to the 1.8 power is equal to x? We are not going to do 10 raised to the 1.8 power. Obviously, we're not going to figure that out. So what are we going to do? We're going to go to our calculator, and we are going to type in 10 And then above that division sign, you have that little up arrow. And you're going to type in 1.8 and then enter. For every problem, you are going to round to the third decimal place. You're going to round to the third decimal place unless I tell you otherwise. So if there's no directions, what decimal place are you rounding to? The third. So this is 63.09 what? 6. If you don't round correctly, if you did 0.95, I will take a point off. So you want to make sure you're rounding correctly. So x is equal to 63.096. Okay, let's say I have 5 to the x is equal to 12. And we want to solve for x. Now, in the past, before we were allowed to use a calculator, I had said, okay, you want to make the bases the same. And once you make the bases the same, then you could set their exponents equal to each other. But is there any way I could make 12 and 5 into the same base? No, there's no power of 5 that I can raise it to make it look like a 12 or vice versa. There's nothing I can raise 5 to make it look like a 12. It's not happening. So what do we have to do? We still have to solve for x, but in order to solve for x, I need to get it out of the exponent. To get it out of the exponent, we're going to take the log of both sides. So this is going to be the log of 5 raised to the x power is equal to log 12 of 12. Now, by me taking the log on both sides, can I pull that x to the front of the log? So now this is going to be x log of 5 is equal to the log of 12. And I need to solve for x. In order to solve for x, what can I do with the log of 5? Divide it on both sides. You got it. So I'm going to divide log 5 on both sides. So now I will have x is equal to log of 12 divided by log of 5. This is what we're going to type into our calculator. So let's go to our calculator. Do you guys see right under the x squared how there's a log? We're going to press that. And immediately when there's no base there, isn't it log base 10? Isn't that what we were dealing with? So we're going to say log, and then we type in whatever that argument was. Was it 12? And then divided by log of 5. Enter, and we're going to go 3 decimal places, so it'll be 1.554. Oh, 544. There we go. Is there any way to change 7 into a base of e? No, there's no way to change 7 into a base of e. There's no way to change e into a base of 7. So we cannot solve this by hand. So I need to solve this. I need to get the exponent out of I need to get the variable out of the exponent. So what am I going to do on both sides to get the exponent out of the exponent? We have to take the log of both sides, but when you're dealing with a base of e, we don't write log. What do we write? ln. We're going to take the ln of both sides. So this is going to be the ln of e to the x plus 2 equals the ln of 7. Well, guys, right here, isn't ln log base e of e raised to the x plus 2? Was there a shortcut for this? in simplifying this? Yeah, what is it? Just x plus 2. So this whole thing simplifies just down to x plus 2. No more ln, no more log. And that will equal the ln of 7. Now my goal is to solve for x, so I'm going to subtract that 2 on both sides. Now, so we don't get confused, I can't subtract that 2 from the 7 because that 7 is sort of paired with that ln of 7. That's the argument of that log. We can't then just subtract 2 from that argument. So you don't get confused, what I'm going to do is I'm not going to put that 2 on the back end. I'm actually going to put it in the front. So I'll make it -2 plus the ln of 7. So you're not tempted to subtract that 7 and make it 5. And this is what we're going to type into our calculator. So we'll go to our calculator. Now I don't want log anymore. Now I'm looking for ln. Do you guys see if you right under the log, right there it says ln? That's what you're going to type in. So we are, what was it, -2? Or was it a +2? -2? Okay. So we are -2 plus ln of 7. So we are -0.054. Okay. So your instinct should not be to use the calculator. Your instinct when you see an equation like this is to try to make it into the same base. But is there any way possible to make 13 and 4 into the same base? No. So then we're going to have to use the calculator. To use the calculator, I have to get the exponent out of the exponent. So what am I going to do? Take the log of both sides. So I'm going to have log of 13 raised to the x minus 4 equals log of 4 raised to the x plus 2. I'm going to pull both exponents in the front. So this is the quantity of x minus 4 times log of 13 equals the quantity of x plus 2 times log of 4. Because this is a binomial multiplied by a monomial, what I'm going to do is I'm actually going to distribute it in, that log of 13. So this is going to be x log 13 minus 4 log of 13. Same thing on the other side. I'm going to distribute in this log of 4. So this is going to be x log of 4 plus 2 log of 4. What are we solving for? X. So what I'm going to do is I'm going to get everything that has an X to the left side and everything that doesn't have an X to the right side. Augie, you with me? You with me? Okay, so everything that has an X to the left, everything that doesn't have an X to the right. So I'm going to keep the x log of 13 here, but then I'm going to subtract x log of 4 to bring it over. And then I'm going to have 2 log of 4, but then I'm going to add the 4 log of 13. What do you think I'm going to do on the left side? Any guesses? Our goal is to solve for x, so I need to get it down to 1x. Okay. I am eventually going to make it 1 log, but before I can make it 1 log, because I can't make it 1 log when they both have an x in front of it. And then if I put them back as exponents, that defeats the whole purpose. Exactly. Before we turn it into one log, which we will turn it into one log, let's factor out an x. So I'm going to pull out an x, and then I am going to have log 13 minus log of 4 equals 2 log of 4 plus 4 log of 13. Now that I got it down to 1x, I'm going to solve. I need to isolate it. I need to get it all by itself. So I'm going to divide. Oops, sorry. Actually, I'm going to leave it. I'm actually not going to change it into division. We don't have to. It's actually better if we don't. I'm going to divide by log 13 minus log 4. So x is equal to 2 log of 4 plus 4 log of 13 divided by log 13 minus log 4. I will show you how to type this into your calculator. There was a lot going on in this problem. Can I go to my calculator? Is anybody still copying? All right, how do we enter this in? We're going to need parentheses. So I'm going to open my parentheses up for the numerator, and I'm going to type in 2 log of 4 plus 4 log of 13. And now I'm going to close the main parenthesis. So that's the end of the numerator. Now we do our division sign, and I'm going to open up another set of parentheses to start my denominator. So this is going to be log 13 minus log 4. And then we're going to double close to end that. Press enter, and we will have 11.057. Okay, I want you to try a couple of these on your own. right, who has answers for me? For the first one, what did we get x to equal? Leah? 2.252. Perfect. For the second one, somebody tell me, what did you get for x?
2.322.
Good, 2.322. Does anybody need me to do either one of these? The second one? Okay, so for number 2, there's no way we can change them into the same base, so I'm taking the log of both sides. I'm immediately going to pull in front that x plus 1 and have x plus 1, that quantity times log of 4 equals log of 100. So working on the right side, isn't this log base 10 of 100? But what's log base 10 of 100? Isn't this the same as log base 10 of 10 squared? Isn't that 2? 10 times what exponent gives us 100? It's 2. So we can simplify that right down. So now we're going to have x plus 1 quantity times the log of 4 is equal to 2. I'm now going to distribute in this log of 4. So we're going to have x log of 4 plus log of 4 is equal to 2. My goal is to solve for x. So I'm first going to subtract the log of 4. So I'm going to have x log of 4 is equal to 2 minus the log of 4. Then I'm going to divide by the log of 4. So in your calculators, you are typing in 2 minus the log of 4 over log of 4. Do you need to see me type it in? We're good? Instead of making this a 2?
Yeah, I just
Kept it log base 10 of log of 100?
and I divided the log
That's fine.
over, and then I subtracted the one after.
That's fine. You got the same answer, right? Yep, you should. Henry, is that what you were going to ask too?
Yeah.
Okay. Yep, you're fine doing that. All right, so now we're going to step it up a little bit. We're going to make the problems a little bit harder.
We're done.
No. 2 more problems. This one might make you a little dizzy.
One.
That would be nice. So to be honest, looking at this, I probably wouldn't really know where to start, but what I would notice is that all of these have the same base of 4. But I can't combine any of them because it's addition between them, not multiplication, not division. There's really not much I can do within that base of 4. But because they all have the same base, and sometimes just seeing a number as a base versus a variable makes things look a little weird. So I'm going to change this to a variable. I'm going to let 4 equal m. So what does this look like now? So now it's going to be m to the x plus m to the negative x over m to the x minus m to the negative x is equal to 2. And for some reason, this looks a lot more manageable than when it was a 4 as a base. Any guesses on what we're going to try to do now? Michael?
Are you able to move the 4s because they have a negative exponent?
I'm not going to do that, and no, you can't because it's attached to the minus sign. So you could do like 4x minus 1 over 4x, but that just makes things a lot worse. So I'm using the m's right now. Any guesses? David?
To multiply the denominator by the 2.
Yeah, I'm going to cross multiply this. So I'm going to do this and this. So this is going to be, are you guys okay if I just distribute right away?
Yeah.
So 2m to the x minus 2m to the negative x is equal to m to the x plus m to the negative x. Now what I'm going to do is the expressions that have the same exponent, I'm going to combine them because they're like terms. So I'm going to subtract the m to the x. So if I have 2m to the x minus 1m to the x, do we all agree we end up with m to the x? And then I'm going to add the 2m to the negative x. So then on the other side, I'm going to get 1m to the negative x plus 2m. Ooh, was I adding or subtracting that? Is that supposed to be? One of these signs are off. Are they not? One of the signs should have been off. 2m.
Yes, 2m. It's a positive 2m.
It should be a positive 2, right? Where are we? I'm trying to find where I wrote it, but I don't see it. 2m to the x.
No, it's not.
Oh, no, we're good. Okay, so this is I thought I wrote a minus. This is a positive 3m to the negative x. Okay, so now what is this? Well, this is m to the x is equal to 3 over, because this is a negative exponent, but that negative exponent is just on the m. I'm only moving the m to the denominator. So m to the x equals 3 over m to the x. Once again, guess what I'm going to do? Cross multiply. So we have m to the x times m to the x is m to the 2x is equal to 3. Now we need to solve. We need to solve for x. I can't make them into the same base, so I'm going to take the log of both sides. So this becomes 2x log of m is equal to the log of 3. Now to solve for x, all I'm going to do is divide by 2 log of m on both sides, since it's all multiplication, right? It's 2 times x times log of m. So I could divide the 2 log of m since it's all multiplied. Divided by 2 log of m. So then I get x is equal to log of 3 over 2 log of m. But didn't we use substitution? What did we say m was? 4. So now I'm not going to make it log of m. I'm going to make it log of 4. And this is what you type into your calculator. When you type this into your calculator, we should get x is equal to 0.396. Yeah.
Does it make a difference if you were to like turn it into log 16?
Where are we? Nope. That would have been fine. You would have been fine with that. Yes.
0.144.
Oh, did I type it in wrong into my calculator? I might have. Hold on. Let me type it in. So we are log of 3 divided by Do you guys do what I did? I got this. Where? On the second one or the first one? The first one you didn't. I don't think you did. Let's see. I always just get parenthesis happy. Oh, so it does make a difference. We need the parenthesis.
For both?
No,
Or
just the second one. The first one, you definitely don't need it. But let's just make sure. There we go. We need it for the second one. So I guess if there's a coefficient in front, you need it. How am I on time?
basically
Almost
not
done.
good.
You have like 3 minutes left.
3 minutes. Is it real 3 minutes or Augie 3 minutes?
3.5 minutes.
Okay. Well, there was one more problem, but we'll do it as a do now tomorrow. We're good.